All right, so in the last video, we selected the voltage divider ratio that we wanted for both the probe inputs, and we selected 1 to 10 for both probes 1 and probe 2. So from here, we're going to do something a bit different. So originally, our oscilloscope was designed to have 4 probe inputs, but as you obviously saw in the previous videos, I did not have 4 probe inputs on my circuit, and that was because trying to run 4 probe inputs at the same time caused the simulation time to become way too long and for the system to run into memory issues, so I only stuck with 2. But originally, the system was supposed to have 4 probe inputs, so you'd have 4 probe inputs, and then you have to choose the voltage for all 4 of those probes instead of just the 2 that I did in the previous video. And from here, we're going to pick which of the probe inputs that we want to use in our system. So like I said, originally there were supposed to be 4 probe inputs, and these were supposed to represent the 4 probe inputs. But in the previous video, we showed we only had voltage select 1 and voltage select 2 because I didn't have enough processing power to run probes 3 and 4 at the same time. So what channel select does is when the oscilloscope has measured up to 4 different inputs from the probes. Now it needs to choose which of those measured inputs it wants to actually focus on and operate on and display. So first, we're going to load in the voltage inputs that we got from the previous video. So this one would be voltage select 1, corresponding to voltage select 1. So I just have to do the same thing as I did before. I go in here, I look for voltage select 1, I open it up, good to go. And then voltage select 2. Same thing, and same importing as all the previous times. So now I don't actually have inputs for voltage select 3 and voltage select 4 because I didn't include probe 3 and probe 4 in the simulation. So for these, it doesn't really matter what they are at this point because I know I'm not going to select them as my inputs. So right now I believe I'll just put probe 3 to be the same as probe 1, and I'll put probe 4 to be the same as probe 2. Not that it would really matter because I don't plan on selecting these probes to be read by the system. So the channel 1 is the primary input channel for the oscilloscope. Operations that only operate on a single signal, such as integration or differentiation, will only operate on channel 1. Channel 2 is more like the auxiliary channel, and for operations that require 2 signals, then you'll obviously use the signals in channel 1 and channel 2. So if we want to add 2 signals, it will add the signal in channel 1 with the signal in channel 2. And if we want to subtract signals, it'll take the signal in channel 1 and subtract channel from signal 2. So since we wanted to measure that full wave rectifier, we needed the subtraction between, or the difference between voltage probe 1 and voltage probe 2. So I'll need the probe 1 in channel 1, and I'll need probe 2 in channel 2. So we have these voltage probe inputs that I just loaded in, and now I have 2 sets of switches instead of one set of switches. I have 2 sets of switches because these channels can be controlled independently. So this top set of switches controls this top mux to control channel 1. So I want channel 1 to be the voltage select 1, this one right here. So I look over here and I see that it's S1 or S2, but remember that we have to start at 0, 0 or 0, 1. So right here I have it set to 0, 0, 0. That way I'll select this line right here and grab the voltage select 1 for my channel 1. And for the second set of switches, I want voltage select 2 as my channel 2. So I have to look over here and I can use either 0, 1, 0 or 0, 1, 1. So here I have 0, 1, 0. This will pull from this line right here, which will give me voltage select 2 for channel 2. So with that in mind, we can go ahead and run the transient again for 1 millisecond. And give it a bit. And as before, as all the other times, it's kind of hard to see right here because I missed it a bit, but our system is still running on plus or minus 12 volts, and this will be the same throughout the entire system. And at the end of the muxes, you may notice this op-amp right here. This is just a buffer here to buffer the input to give it isolation between sections and to help boost the signal power. So since our simulation is almost done, we should see channel 1 and channel 2 being selected as signal 1 and signal 2. Notice how it looks almost exactly the same as the voltage select previously because we only did 2 probes. If we had done 4 probes, or if we had set channel 1, or if we had set voltage select 1 as channel 2 or something, then obviously they would look different, but as of right now, they look almost the same as last time. So with this, we're going to export it back out the same as how we've always done it. You're going to have to export it as a text file. I'm going to save this as channel select. So I save that as channel select. And with that, I just need to open it back up in Excel. So I go over here, open it back up in Excel. I find the signal, and I put it as channel select. Again, it's tab delimited, so always make sure that you're delimited by tab to separate it out. So now we need to have two channels, so we also need to split it again. But again, every time we import and export out Tina, you always got to check to make sure the number of samples that you have. So notice again that every time we use the analog mux, the number of samples has increased by 10 times its original input. So originally we decreased it back down to 397, but now it's back up to 3,900 again. So in order to reduce the number of samples back down again, we'll need to use the filter macro again. So we go over here, macro. So filter macro is the same as split macro, except it also grabs only every 10th sample to reduce the number of input samples. So if we scroll down here and we check, we see that we're back down to the same number of samples as before. And so with this, we just need to save these as text files with tab delimited, because Tina can only read tab delimited files. So I save this one as the channel 1 signal. So I save that, and then I save this one as the channel 2 signal. And again, tab delimited. So after the channel signals have been selected, the oscilloscope system will perform a bunch of operations on those channel select signals. And I'll do all these operations in parallel. So I'm going to go through each of those operations one by one, but in reality, they're all done in parallel. And then the system will choose which operation to output. So with these channel signals, a lot of operations will be performed on them.